Hello, my name is Dr. Genevieve Dunton from the University of Southern California, and I'm going to be giving a conceptual overview of why you'd want to use the MixWILD software, and then discuss some research applications and questions that you can address using the MixWILD software. So why use MixWILD? Before we address that question, I want to highlight the difference between repeated occurrence health behaviors and outcomes and limited occurrence health behaviors and outcomes. So with the repeated occurrence health behaviors and outcomes, these are activities or events that take place every day or multiple times per day. So these could be behaviors including physical activity, healthy eating, smoking, or sleeping every night. They also could include health indicators and biomarkers such as your blood pressure, your hemoglobin A1C, which is an indicator of blood sugar, and your heart rate. And that's in contrast to limited occurrence health behaviors and outcomes. And these are things that happen much less frequently and often rarely. So they might be vaccinations that take place once a year, or diagnostic tests such as mammograms or pap smears that take place every few years. They can also be severe health conditions and health events such as heart attacks or cancer diagnoses that may occur hopefully never or only once or twice in a lifetime. So MixWILD stands for Mixed Analysis with Intensive Longitudinal Data. Now we are interested in using intensive longitudinal data with the repeated occurrence health behaviors and outcomes that I mentioned. And what intensive longitudinal data does is it collects high frequency, high density repeated measures data over a micro time scale. So they might be collected at intervals of seconds or minutes, hours, or days at most. These data are collected in real-world settings. They often occur through wearable devices that collect body movement and motion, biological responses, your geographic location through GPS. It could include measuring social interactions and communication patterns in real time, or self-reported moods and stress levels and context through ecological momentary assessment, which are surveys on smartphone devices. So we can use ILD to examine the momentary effects of time-varying variables on health behaviors. And by that, we can look at a health behavior and look back in time and see what happened right before that behavior occurred. So we can look at the antecedents to that behavior, and then we can look at the concomitants, or the things that occurred during the behavior, and then we can look right after the behavior and look at the consequences of engaging in that behavior. And this is all over a very short time scale of minutes or hours or just partial or whole days. So some examples of these momentary effects of time-varying predictors on health outcomes and behaviors include work that we've done with children, and we've looked at whether affect, our mood, predicts physical activity. And we looked at in the next 30 minutes. And so we found in this case that children that felt more energetic were more physically active in the next 30 minutes right after the prompt. And so this is an example of a momentary effect. We can also look at concomitants, or things that occur during a behavior. And in this case, we looked at contextual influences on the affective response, or how people emotionally respond during a physical activity behavior. And when we looked at this, we found that their affective response during the health behavior differed depending on the context. And they felt more positive affect when they were not alone engaging in physical activity, and they felt less negative affect when they were outdoors being physically active. And finally, we can look at momentary effects in terms of the consequences. So does physical activity predict affect in children? So just looking at the opposite direction. And in this particular study, we found that kids that were more physically active in the 30 minutes before an EMA prompt reported higher positive affect during the prompt, and also feeling more energetic during the prompt, so after the behavior. So these are all examples of momentary effects of time-varying variables on a time-varying outcome. And that's a very common use of intensive longitudinal data, or ILD. So a less common use is looking at the aggregated intra-individual effects of these time-varying variables on health behaviors. And what we mean by that is, instead of just looking at the momentary effect, we can look at all of the individual data points for a variable and aggregate them together to create an intra-individual mean. And then we can do the same thing and create an intra-individual variance, or how much an individual varies compared to other individuals. And we can also aggregate them to look at intra-individual slopes. And by that, we mean how a relationship between two time-varying variables may be different between one person and the next person. So I'm going to show you an example of what this means. And here's some research questions that you may be interested in answering. So here on this figure, you can see what these aggregated inter-individual effects of time-varying variables look like. So we have subject 1 on the top and subject 2 on the bottom, and they have pretty different patterns of response. And the x-axis is occasion or time, and the y-axis in this case is looking at their positive affect. And so with subject 1, when we look at the green line, this is their intra-individual mean. That's the mean of all their responses for affect over time. And this subject 2 has a lower mean. When we look at this shaded band of yellow, we can see that is the intra-individual variance, or how much that individual varies in their responses over time. And you can see that that band is narrower, so they vary less than this individual who has a wider band down here, who has more higher level of intra-individual variability. And the last thing I want to show you is the intra-individual slope. And this is a little bit more challenging construct, but what this is looking at is the relationship between two time-varying variables. And in the case of the subject 1, you can see that the relationship is pretty tight. When one variable, which is this blue dot, is higher, this orange triangle is also higher. And when the blue dot is lower, the orange triangle is also lower. So that suggests that there is a relationship between those two variables, and a positive relationship. That's pretty tight. But this subject down here doesn't seem to have much of a relationship between those two variables. Sometimes when the blue variable is higher, the orange one's lower. And sometimes when the blue variable is lower, the orange one's higher. So this one does not have a very strong slope. They have a lower intra-individual slope. So what we're interested in using MixWILD to do is then to look at these relationships between these intra-individual effects on different health behavior outcomes. So here's an example of what we can do. So we can look at the intra-individual variance and slopes of these time-varying variables and how it might predict a subject-level health outcome or health behavior. And then we can also test a mediation model. So we can look at how a time-invariant variable, and that might just be age or demographics, might predict intra-individual variances and slopes of these time-varying variables. And then that, in tune, predicts the physical activity or sedentary behavior outcome. And then we can also look at moderation effects. These intra-individual variances and slopes could also moderate or interact with the effects of time-invariant variables on a subject-level health behavior or outcome. And I'm going to show you some examples of these. So in this first example, we looked at how an intra-individual variance predicts a subject-level outcome. So we were curious how variability in feelings of energy are related to the odds of meeting physical activity guidelines, and that's a person-level outcome. So we found here that people that had more variability in feelings of energy were less likely to meet the physical activity guidelines. And here I'm going to show you how an example of how we can look at intra-individual variance as a moderator of the effect of a subject-level factor on a subject-level outcome. And in this case, we looked at physical activity variability as a moderator and looked at the interaction between that and weight status in predicting perceived stress. And so we found that individuals with obesity had higher levels of perceived stress, but that was only for individuals with high, as you can see here, high day-to-day variability in physical activity. Individuals who did not have high day-to-day variability or who did physical activity pretty consistently day-to-day had no relationship between perceived stress and their weight status. And here I'm going to show you how we can look at intra-individual variance as a moderating effect of the effect of an intra-individual mean on a subject level outcome. So this is looking at the interaction between an intra-individual mean and an intra-individual variance. You can see here that individuals with lower mean positive affect had higher alcohol consumption, but that was only for those with low variability in positive affect. So you can see that's right here. So this line. If they had high variability in positive affect, we saw the opposite effect. So in this case, the variability in affect moderates the effect of the mean affect on their alcohol consumption. So next I want to show you an example of how we can look at an intra-individual slope predicting a subject level outcome. And in this case, we were looking at whether the time varying relationship between being outdoors and their concurrent levels of physical activity were associated with how active they were at the person level several months later. So we found that participants who had more momentary MVPA when outdoors versus indoors. So this is this slope here, the intra-individual slope is the relationship between momentary physical activity and being outdoors. And you can see that when they had a higher slope for that individual, they were more overall physical activity 6 months later. So now I'm going to show you how we can extend this even further, and we can look at how intra-individual means and variances and slopes predict change in an outcome over time. So the previous examples just showed how you can look at a subject level outcome, but now we can look at change in an outcome over time. So in this case, we are looking at how intra-individual variance predicted change in children's physical activity over time. And the intra-individual variance we were interested in was looking at positive affect variability measured by EMA. So we found that kids that had more positive affect variability across the day had a steeper decline in physical activity over time. So in this case, our outcome is changing over time, and it's being predicted by an intra-individual variance. And then lastly, I'm going to show you how we can look at an intra-individual slope predicting a change in an outcome over time. And this one's a little complicated, but it's the last example I'm going to show you. And in this case, we looked at an intra-individual slope between days with higher negative affect and the sleep they needed on the night following that day. So that's a relationship between two time varying variables, negative affect on a day and how much sleep they needed the next night. And we found that children who needed to sleep more on nights following days with higher negative affect, so in this case, that was a higher intra-individual slope, you can see by this line, they had a slower rate of decline in generalized anxiety across 3 years. And this is across early adolescence. So those who declined more in anxiety over those 3 years had a lower intra-individual slope, or they didn't need as much sleep after days when they had higher affect, negative affect. So the goal of this short presentation is to just give you an overview of the conceptual questions and research applications that you can address with MixWILD software. And just to clarify what the software does, it's a two-stage model, and you're going to hear more about that in the next video. But this first stage, what it does is it estimates these intra-individual means and variances and slopes as random effects in a mixed effects location scale multi-level model. And so then you take those random means, variances, and slopes from the first stage then and put them in the second stage as predictors of a subject level or a time varying outcome. And that's going to be either a single linear logistic or linear model or a multi-level linear or logistic regression model. So you're going to hear more about that in the next video, but I wanted to start to connect the dots between this conceptual questions and an overview of what the MixWILD software will actually be doing. So I hope you have fun using the software. Thanks.